Well, good morning, everybody. Happy day. So I asked you all to do page 19, right?
Yeah.
So if you would, let's get it out, and we're gonna go through, and we're gonna just mosey through them, and then by the end of the period, you'll be able to turn in both 19 and 20 to me, because we'll get the back side done as well. But I want to go through the front side, and I want to make sure you're comfortable with it, because one thing that we do understand with math is there is way too many things that can take place with math, and when to use and how to use. So just looking at problem number 1 on page 19, does everybody feel comfortable knowing that that is 1 root 5 plus 3 root 5, and we add them together, and we're just counting out. So we have 4 root 5. Does everyone feel comfortable with that on number 1? That's most basic. Look at that. Jake's got his phone out already. I've only been talking for 5 minutes.
I just had to join a Kahoot session.
I'm not even doing Kahoot. Who did you jump on with? You're just finding other sessions and Kahoot?
Well, no, my friend sent it to me. He told me to join.
Because it's always fun when the teacher's going, why is there 74 people on Kahoot and there's only 12 people here? All right. So problem number 2, same exact idea as problem number 1. It's the exact same radical, correct? So we're going to go 2 radical 3 or 2 root 3 minus 7 root 3. So 2 minus 7 is negative 5. So I get negative 5 root 3. And those are the exact same. But number 3 is where I want to start working them out a little bit. So everyone feel comfortable with problem number 1 and 2?
You probably just go over just like one.
1 and 2?
Yeah.
Well, if you see 1 and 2 done, or if you see number 3 done, you're definitely going to know how to do number 1. They're automatically the same radicals.
Can you at least do one? Just one.
Okay.
You can visible. Yeah.
All right, he wants to see official. All right, pick one, Brandon. I'll do number 2. That's the tougher of the two because it's subtraction, which that's everybody's fun. All right, so 2 root 3 minus 7 root 3. We're adding or subtracting these. It's the exact same radical, so we can just go ahead and add it. You treat the radical like it would be an x. It's not going to increase in value. So you're just counting. So 2 minus 7 is negative 5, so I get negative 5 root 3. And that's done. There's no further to go. All right? Brandon, feel good now? All right. Number 3, we have 4 root 20 plus 2 root 45. So we want to add these together. We can't add them right now because we have 2 different radicals. Agreed? Okay, so we want to see if we can break our radicals down. So 20 breaks down to 4 times 5. And the reason I'm choosing 4 times 5 and not 2 times 10 is 4 is the largest perfect square that goes into 20. Is that information okay? And then for 45, I'm going to break 45 down to 9 times 5. And the reason I'm using 9 times 5 and not 3 times 15 is 9 is the largest perfect square that goes into 45. Is that okay? So let's bring that up. All right, so with this information, what is the square root of 4? 2. So I'm going to multiply whatever that square root of 4 is, which was 2, times that. So I'm going to get 8 square root 5 plus, does everyone agree with that first move?
Wait, I have a question.
Go.
Oh, okay. So if you multiply the outside and the inside, that automatically becomes the outside, so it doesn't stay like on the inside.
Because I took the square root of 4, which is 2, 2 times that 4 becomes 8. So I'm not multiplying the inside. I'm taking the square root of what's inside because 4 is your perfect square, and then that comes outside. So the same thing with this. What's the square root of 9? 3, right? So the square root of 9 is 3, so I'm going to multiply that times the outside, so I get to that. Does everyone feel comfortable with how I got those numbers?
Yeah.
Now I'm going to I have the exact same radical on both. Now I'm just going to count them up. So I have 8 radical 5s here and 6 there, so that gives me 14 root 5 for an answer. Okay, notice again, inside the radical did not change, did it? It's acting like a variable, kind of. We good so far?
Yes.
All right, let's take a look at problem number 4. And I'm actually going to do this on split screen. Dual page. All right, so you can see what we did there. So number 4 we have 3 square root 18 plus 7 square root 50. I cannot add these together as they sit because I have two different radicals. Does that information make sense? So I think I could probably start breaking 18 up. I'm going to break 18 to 9 times 2. The reason I'm using 9 and 2 is 9 is the largest perfect square that goes into 18. If I chose 3 and 6, neither of those are perfect squares. And then 50, the largest perfect square that goes into 50 is 25. So I get 25 times 2. Does that make sense?
Yeah.
So then I'm going to take the square root of my perfect square. So what's the square root of 9? 3, and that 3 gets multiplied with what's on the outside, which happens to be a 3 as well, right? So on this one, I'm going to get 9 square root 2. Does everyone see where that 9 came from? I took the square root of the inside 9, which was 3, and multiplied it times the outside. And then on this next one, I'm going to take the square root of 25. What's the square root of 25? 5. I'm going to multiply what's on the outside. So what's outside then? 35. Good. So now I have 9 root 2 and 35 root 2. We're adding them together. So that's going to give me 44 root 2. Is it settling in a little bit? Okay, so number 4, let's switch over to the screen here a sec. Okay, got number 5. Number 5, we have 2 square root 36 plus 3 square root 12. Okay, what's special about this right here? It is a perfect square. So what's the square root of 36? 6. So what does this become then? 12. Good. Plus, and then this is going to break down to 3 times 4 times 3. The reason I'm using 4 times 3, not 6 times 2, is 4 is the largest perfect square that goes into 12. So what's the square root of 4? 2. So what does this become? 6 square root 3. Can I go any further now? So I have a whole number added to a radical, so it has to stay split apart like that. May I go to number 6, please? Hey! Number 6. So let's move that over. Number 6. Here we go. 5 square root of 80 minus 4 square root of 24. So everyone agrees I can't add or subtract these right now, correct? They're not like terms. Excuse me. So I have to think about what's the largest perfect square that goes into 80, and I would say that's the same thing as 16 times 5. Agreed? Now some of you are looking at it going, gosh, why didn't he just choose 4 and 20? Well, 4 truly is a perfect square, right? But 16 happens to be the largest perfect square that goes in there. And then I'm going to break 24 down to 4 times 6. The reason I'm not using 3 and 8 is because 3 and 8 aren't perfect squares, where 4 and 6 are, or 4 would be, okay? So the square root of 16 is what? 4. So what does this part become? 20 root 5. Awesome. Minus, what is this? What's the square root of 4? 2. So what does this become? Negative 8 square root of 6. Are these like terms or not? No. So that's final answer. It's done. Now, I want to pause at that for a second. That's a bigger answer, right? You're still leaving a mathematical operation in there. Agreed? So remember when we started talking about exact numbers? And you want an exact number, especially when you're dealing with, like, if we're going to go to Mars, we want an exact number to go in. That's actually how the computer will read it. It'll read it like that. That's an exact value. It knows that is an exact value. If you put a large decimal into the computer, there's an error that's going to take place. This is less work and less iterations of how a computer program would work if it comes out to this. And that will allow that, bless you, that will allow an exact location. Think about your GPS on your phone. You with me? So that GPS comes within 3 feet. Okay? So 3 feet around you. So figure it's got an error range of about 6 feet. Agreed? Does that make sense if I say that? Is that pretty close? Now, let me ask you this. Do you think that we have technology right now that would allow us to get closer than that 6-foot range? Yeah, but what's prohibiting your phone getting closer than that 6-foot range? Money. It costs more. It is more expensive to run the higher exact location than it would be within 6 feet. Now, that's not to say that, once they get to the iPhone 15 or the iPhone 20 or whatever iPhone you get to, I don't know, who knows? It will eventually get down to no longer a 6-foot span. It'll get down to 2-foot span or a 1-foot span. Why is that? Because as technology continues to improve, the price comes down. Okay? Does that make sense? What will us going to Mars do for our technology that we have available for us? It'll continue to improve it more and more and more. Why is that? Because once we ship somebody out into outer space or a group of people out in outer space, the errors that could take place could cost life, could cost a lot of, it could cost, you have to abort the mission, so you have some sort of thing that will allow your aircraft or your spaceship to come back to Earth when that's not even there. Does that cost money? Absolutely. So the demand for us to be correct is really incredible. Okay? And that's where that kind of exact numbers starts coming. And we're just at a preliminary foundation of this. We're not like NASA with the math that we're doing, but that's the same idea. Okay? They do the same thing with surgery as well. A lot of times they do laparoscopic surgery now rather than cut you wide open. So they put 3 or 4 holes in you that are small. They fill up your cavity with CO2 gas because CO2 gas exists in your system. So that kind of inflates your belly. Lets you go inside, fix what's broken. What does CO2 gas do? It'll dissipate out of your body. Right? So once they pull those out, you go, it's not like a balloon. Right? How does CO2 gas come out? You burp it out or you fart it out. Is it natural? Uh-huh. So, there's so many different things that you guys are seeing that are pretty incredible. All right, let's take a look at number 7. So again, I go off on a little tangent because I want you to realize that there is value in what we're doing. It's not just that, we were bored, so we decided I'm going to throw radicals at you guys. There's rhyme and reason to our madness. You guys understand that, you probably don't realize this, but teaching's all about me. We make it all about me, right? Right now. The better I teach you, the better your education becomes. The better your education becomes, the better career choices you will have available for you, which means you will make more money. And I'm a state-paid employee, so the more money that's taken in by taxes through here means that my retirement's better. So a teacher who says, I don't care about teaching, they're screwing up their retirement. No. I'm going to teach you guys the best I can because it's all about me. Look at that. And you're like, wait a minute. Don't jerk me about he's going to make me work harder so he can have better. Show him. All right. Hey, I have this whole thing squared. So that means that I'm taking 3 root 7 and I'm multiplying it by another 3 root 7. Agreed? But we could kind of shortcut it a little bit and say, okay, that goes 3 squared and 7 squared. So that gives me 9. And then that becomes 49. Now, what's special about 49? It is a perfect square. So what's the square root of 49? 7. So 7 multiplies with that gives me 63. Sound good? Number 8, can I go to that? Hey, how many 10 root 2's am I multiplying together on number 8? 2 of them? Alright, so that comes here and that comes here. 10 squared is 100. Root 2 times root 2 is root 4. What's the square root of 4? 2. What's my answer? 200. Love it. Okay. Everyone feel comfortable so far up through number 8?
Yeah.
Any part of that? Yeah.
No. So if it's not a perfect square,
Then you just leave it there.
okay. You just do the vertical.
Okay. Yep. All right, number 9. Number 9 appears we're going to use the distributive property here. So I have 3 square root of 5 times the square root of 2 plus 3 square root of 5. Okay, so I'm going to distribute that here and here. So on the first one, it's going to become 3 root 10. I multiply inside, inside, so under the radical, to outside, outside. And then this next one is going to become 9 root 25. So what number was sitting right here in front of this root 2 originally? Had been a 1, so that was basically 3 times 1, 3. Root 5 times root 2, root 10. 3 times 3 is 9. Root 5 times root 5 is root 25. Is root 10 a perfect square? No. Are there any perfect squares that are in it? No. 2 and 5? Nope, they're not going to work. So this is going to stay as 3 root 10 plus, what's the square root of 25? 5. So what does this become? 9 times 5, which is? 45, right? There's my answer. 3 root 10 plus 45. Done. Okay, could I have written it 45 plus 3 root 10? Absolutely. Which one's right? Both. Which one do I prefer? Both. Hey, number 10. I have root 3, and I have 4 minus 2 root 3. So I'm going to distribute here and here. So 4 times root 3 is 4 root 3 minus 2. Root 3 times root 3 is root 9. I can't break this down any further, so it's staying as is. What does that become? Yeah, negative 6. Good. So I could have written this as negative 6 plus 4 root 3, or I could leave it like this. It's your choice. Hey, is this negative or minus 6? Is that under the radical sign? Is that minus 6 under the square root sign? Number 11. Number 11. You know what number 11 is? 4-letter F word. You guys know the 4-letter F word? Foil, right? Like, dude, we almost said it this time. Foil. All right, so by foil, I'm going to go 1 times 1 to get 1. Agree? Then I'm going to go 1 times negative 3, so I get negative 1 root 3. Or I could write just negative root 3. Doesn't matter. And then inside, let's see, inside I'm going to get that times that. So that's 1 times root 3, positive. And then I get root 3 times that, so I get negative root 9. What do you think? 4-letter F word up there. Foil. First, outer, inner, last. Okay? All right, so what can you tell me is going to happen to those right there? Do they cancel? Yeah. I have a negative root 3 and I have a positive root 3. I'm trying to combine them. They're gone. And then, hey, what is this going to come out to? Negative 3, so I get 1 minus 3, which is? Negative 2. There's my answer.
So sometimes you get a complete answer.
Yeah.
Break through it all the way.
Yep. And then let's take a look at problem number 12. Problem number 12, we have the square root of 98. And then I have x5, y3. So we need to start breaking it into square roots. So I have the square root. I know that 98 is the same thing as 49 times 2. The reason I'm choosing 49 is that's the largest perfect square that's in 98. If I want to make x to the 5th a perfect square, I need to break it into x to the fourth and x. If I multiply those back together, I get x to the fifth. With that, then I have to break up y, so I get y squared y. So now I have a bunch of perfect squares up there, so we'll underline each one. Square root of 49 is 7. The square root of x to the fourth is x to the second. Remember, you just take half of it when you take the square root of an exponent. And the square root of y to the second is y. Under the radical, I'm left with a 2 and an x and a y. That problem's done. Okay, so the front side is done. I had asked you to do it for homework. I didn't come by and take a look at it. So what I want you to do is I would like to have you take the next 10 minutes and complete 13 through 18. You can work with each other. You can work alone. You can come ask me. But you have 10 minutes. So at 53, we're going to go over them. Got it? All right. Eyes up here. Go back to your seats too, please. All right. Problem number 13. Square root of 144 is 12. Square root of x to the 6th is x to the 3rd. Square root of 81 is 9. And then that needs to break into this. So that's going to give me square root of y squared is y, and then I have square root y down here. Okay? So that's the first part of that problem. Other part that you should start recognizing is the square root of 12 over 9. So 3 goes into that 3 times, 3 goes into that 4 times. So I can reduce that fraction. So I get 4 over 3. I also need to multiply top and bottom by root y. Okay, so on top I'm going to get x to the 3rd root y. That's going to stay like that. Root y times root y is y squared. What is root y squared? What is root y squared? Y, and then I have to multiply times that, so I get y squared outside. That's definitely a tougher problem. Kind of a lot of moving parts to that one. May I move to the next? Well, I'll just go to the next one. 13 will stay right there for you. All right, problem number 14. We're going to multiply 5 times 2, that's 10. And then, help me out, what is 21 times 14? 294. Thank you. 294, thank you. All right, so 294. So now we have to figure out the biggest perfect square. Brandon, did 49 go into that?
Yeah,
6 times? Sweet. So 49 is the largest perfect square that works. So 49 times 6 is the same thing as 294. And the reason I was able to see that 49 quickly is I know that 7 works here, right? 7 works here. 7 times 7 is 49. So that kind of led me to think of 49. Can 6 be broken down any further to perfect squares, or is it good? Good. So what's the square root of 49? 7. So that's going to get multiplied here. So what's outside now? 70. What's left inside? 6. Done. Okay? All right, so there's that last one worked out. Problem 15, it does appear that everything's a perfect square, including our exponents. The exponents are all even. So square root of 16 is 4. Square root of y to the 4th is y squared. Over square root of 49 is 7. Square root of x squared is x. That problem's done. That was nice. They gave us a nice perfect square. Well, yeah, sometimes we get an easy one thrown at us. I got that one because I just copied the download you wrote. All right, 16. We're going to multiply outside, so we get 8. Then we're going to multiply inside, so 3 times 6, that's 18. X times x is x squared. Y times y is y squared. Let's break 18 down into a perfect square. So what times what? 9 times 2. Good. All right, so I have 8, and then I have this being 9 times 2. I'll leave x squared and y squared as is because they're both perfect squares right now because they are even exponents. What's the square root of 9? 3. So that gets multiplied out here, so I get 24 outside. What's the square root of x squared? Square root of y squared. What's left inside? 2. Good. Problem's done. All right, I'll move 16 over to that board. Number 17, it just wants us to take care of the denominator not having a radical. So what am I going to multiply top and bottom by? Root 2. So root 2. So on top I get 8 square root 2. Root 2 times root 2 is root 4. Root 4 is what? 2. So can I reduce outside right now?
Yeah.
Yeah, 2 goes into, so if 1 goes into there 4 times. So my answer is 4 root 2.
You have to reduce it like that?
Yep.
You do?
If you didn't reduce it, I would take 1 point off. 1 point off the 2 point problem. Okay. Last one?
For 18, you just simplify it?
I don't know. Look at it. Oh, shoot, yeah. What is that? 7 over 6? Really? Ah, done. All right.
Wait, do you not have to carry the little bracket thing?
No, because I took the square root of 49, which is 7. Square root of 36, which is 6. 7. Square root of 36 is 6. Right? All right, do me a favor. That sheet of paper that you all have right there, put a 4 at the top. Put a 4. It's in the grade book. It's in the grade book now. Put a 4 at the top. You do not need to turn it in. Okay? So, just a little information. So today is Wednesday, so we got this taken care of. Thursday, we're going to continue with review. And then Friday, we have a quiz. Okay, so I hope to kind of be able to be comfortable like this going through and do the best we can. So I would like for you all to, why don't we have page 21 and 22, page 21 and 22 tomorrow. I will mark that off tomorrow. So that'll be in the book. Sound good? So you still have a few minutes to go through that. And I told you to put a 4 on that last one, right? Do not pass it up. Put a 4 on it. I already put it in the grade book.